one of the most fascinating objects in our solar system, the Psyche asteroid. It's metallic, it's mysterious, and NASA has a spacecraft on the way to explore it. But why is this asteroid such a big deal? What could it teach us about the early solar system, and even about ourselves? Stick around, because we're unpacking the hidden value of Psyche, from its discovery to its billion-dollar NASA mission. Psyche, officially 16 Psyche, is one of the largest asteroids in the main belt between Mars and Jupiter. It was discovered in 1852 by Italian astronomer Annibale de Gasperi and was the 16th asteroid ever found, which is why it carries the number 16. What makes Psyche unique is its composition. Most asteroids are made of rock or ice, but Psyche appears to be made largely of metal, mainly iron and nickel, the same materials found in Earth's core. That's why scientists think Psyche could be the exposed core of an early planet that never fully formed. Billions of years ago, during the chaotic birth of the solar system, protoplanets collided. One of those collisions might have stripped away Psyche's outer layers, leaving behind its dense metallic heart. If that's true, Psyche is like a time capsule, a window into what lies deep inside planets like Earth and Mars, which we can't directly reach. Why scientists? Care studying Psyche could answer one of planetary science's biggest questions. How do rocky planets form metal cores? On Earth, our metallic core generates the magnetic field that protects us from solar radiation. But we can't drill down to see it. It's thousands of kilometers below us. Psyche, on the other hand, might be a core we can actually visit. If we can learn what Psyche is made of and how it formed, we'll get direct evidence of the processes that shape the inner planets. There's also an economic angle. Because Psyche appears to be rich in metals like iron, nickel, and possibly even precious metals such as gold and platinum, some estimates have claimed it could be worth trillions of dollars in raw materials. Now, that's mostly a fun thought experiment. It's not practical or ethical to mine it anytime soon, but it shows why Psyche captures the imagination of both scientists and the public. The NASA Psyche Mission. To unlock Psyche's secrets, NASA launched the Psyche spacecraft in October 2023. It's part of NASA's Discovery program, designed to send smaller, lower-cost missions to explore the solar system. The spacecraft is equipped with several powerful instruments, a multispectral imager to capture detailed photos and analyze surface composition, a gamma ray and neutron spectrometer to identify what metals and elements are present, a magnetometer to detect any leftover magnetic field, which could confirm Psyche's origin as a planetary core, a radio system that also doubles as a technology demo for NASA's deep space optical communications, basically testing high-bandwidth laser communication from deep space. Psyche is taking a solar electric trajectory, powered by large solar panels and efficient ion thrusters. It will take about 6 years to reach its destination, arriving around 2029, and will orbit Psyche for roughly 2 years of scientific observation. What we expect to learn. Once the spacecraft arrives, it will map the asteroid's surface features, gravity field, and composition in unprecedented detail. There are 3 major questions scientists hope to answer. Is Psyche truly a planetary core? If it is, it means we'll finally have a direct look at material that usually hides deep inside planets. How did it form and evolve? Psyche could help refine models of planetary differentiation, the process where heavy metals sink to form cores while lighter materials float to the surface. What is its surface like? Until recently, we didn't know whether Psyche would look shiny and smooth like metal or rugged and rocky. Observations from telescopes and radar suggest it might be a mix, possibly covered with metal-rich dust or rock that has been melted and resolidified by impacts. Every image and measurement will give scientists a clearer picture of what the early solar system was really like. How Psyche differs from other asteroids. So what makes Psyche really stand out among the millions of other asteroids orbiting the Sun? To answer that, we have to look at how asteroids are classified. Most fall into two major families: C-type asteroids or carbonaceous asteroids. These are dark, porous, and made mostly of clay and silicate rocks. They make up about 75% of known asteroids and are thought to be the most ancient. Basically leftovers from the solar system's formation. S-type asteroids, or silicaceous asteroids. They're brighter, made of stony materials mixed with nickel and iron, and make up most of the rest. But Psyche belongs to a much rarer third group called M-type, or metallic asteroids. These are only a small fraction of the total asteroid population, maybe a few percent. And Psyche is the largest known example. Now here's the interesting part. Even though we call them metallic, not all M-type asteroids are created equal. Some are mostly metal, while others seem to be rocky bodies with just metallic patches. Scientists have used radar observations to study how reflective each asteroid is. Kind of like shining a flashlight and measuring how much light bounces back. Psyche gives one of the strongest radar reflections ever recorded, suggesting that its surface could be 60% metal or more. Still, there's a twist. If Psyche were purely metallic, its density should be extremely high, similar to solid iron. But measurements of its mass and volume from telescope data show that it's actually less dense than expected. That tells scientists a few fascinating things. Psyche might not be a solid block of metal. It could be a porous rubble pile, fragments held together by gravity, with voids or spaces inside. It could be a mixture of metal and rock, perhaps the result of ancient collisions that broke off pieces of its surface or mixed in debris from other bodies. Or, and this is the most intriguing, its surface may be covered in metallic dust or regolith that formed after billions of years of impacts, micrometeorite strikes, and solar wind exposure. In other words, Psyche may be wearing a kind of cosmic weathered armor that hides its true interior. By comparing Psyche with other metallic asteroids, scientists can test different theories about how they formed. For instance, smaller M-types might just be chunks of Psyche itself, broken off during ancient collisions. Others could represent entirely different pathways of planetary evolution. There's even evidence from infrared data that Psyche's surface has patches of silicate rock mixed with metal, hinting that it could have once had a crust or mantle before those outer layers were stripped away. All of this makes Psyche a kind of missing link in our understanding of asteroid diversity. It bridges the gap between rocky worlds and metallic cores, between the outer crusts of planets and their deep interiors. So, when NASA's spacecraft finally arrives and starts scanning Psyche, every radar ping and photo will help determine not just what Psyche is, but what it isn't. We'll be able to confirm whether metallic asteroids like Psyche are remnants of destroyed protoplanets or something entirely different. A unique class of worlds that formed in ways we've never imagined. Broader impact and future exploration. Beyond science, the Psyche mission is a testbed for future exploration. If we can successfully send a solar electric spacecraft deep into the asteroid belt, map a metal world, and communicate back with lasers, that paves the way for future missions to even more distant targets, including potential resource missions or human precursors to Mars orbit. It's also an example of collaboration. NASA's Psyche project is led by Arizona State University and managed by the Jet Propulsion Laboratory, with instruments contributed by universities and space agencies across the US and Europe. So Psyche isn't just a mission to one asteroid. It's a step forward in how we do planetary science as a global community. To sum it up, Psyche is more than a piece of metal in space. It's a window into the deep past, a possible planetary core, and a laboratory for learning how worlds like Earth first came together. Over the next few years, as NASA's spacecraft approaches its destination, we'll be getting closer to answering one of the most fundamental questions in planetary science. What are we made of? And how did it all begin? Thanks for watching. If you enjoyed this deep dive, hit that like button, subscribe for more space content, and let me know in the comments what you're most excited to learn from the Psyche mission.